Alright, here's what we're going to be doing. We're going to be doing rational functions, putting it all together. So basically we're using all of the techniques that we have, and we're figuring out as much information as we can. I'll tell you what, why don't we just, I don't even know exactly what we want to do with this, but I'm going to take a look at, alright, here, let's try this one. F of x, which one's f of x? Oh, okay. F of x, I want to graph that. X squared minus 4. That one's not that interesting to graph, to be honest with you. That is a straight up parabola. Move down 4. Okay, that's pretty simple. Let's try this one. X. Oh, let's try R of x. I wonder what this thing is asking us to do. It's basically going to ask us to graph 1 over f of x or whatever. 1 over g of x. Let's see the hardest thing it's asking to do. Okay, here we go. This might be interesting. Oh, okay. Let's graph this. Let's do this one. Let's put all this information together. Let's try to graph this as best as we can. H of x over r of x. H of x is x squared minus x minus 2 over x cubed plus 10x squared plus 16x. Because that's what h of x is, and that's what r of x is. Okay? So, what I'm going to do is, what I've been giving you is I've been giving you the functions already factored. And I've been asking you to graph that. Then I've also been giving you the graphs, and I've been asking you to find the standard equation by first finding the factored equation and then multiplying it all out. Now what I'm doing is I'm straight up giving you the standard form, which is actually probably the hardest one to deal with because you got to turn that into factored form. Now, factoring this, okay, I'm just going to deal with the numerator here. I've got an x here and an x here. I need something that multiplies out to negative 2. So I know that it's going to be positive and a negative because it needs to multiply to be negative 2. I need to go for the number 2, so I'm looking at maybe negative 2 and positive 1 because I need to add these numbers, the 1 and the negative 2, to make this middle number, which is negative 1. 1 plus negative 2 is negative 1. If you don't believe me, FOIL out the numerator and you'll see that this is the same as that. Alright. There is no really good way of factoring out x cubed things. There actually is one trick that I can think of that I never taught you, but you don't need that trick, and I don't think that, I mean, there's a reason why I never taught it to you. Before I factor out or deal with this x cubed, I can pull out an x because there's an x at least in every single one of these. So I have an x times x squared plus 10x plus 16. Now this one, I already taught you how to deal with that. That one you can just straight up factor. So let's keep going with this problem. X, and then this second part can be factored into x. I'm going to need a plus and a plus. What multiplies out to be 16 but adds up to be 10? That would be 8 and 2. Now I can't cancel anything in the numerator and the denominator because those are, I mean, they're all different. So this tells me the graph of this would look like, let's see, I would have 3 vertical asymptotes, and that would be occurring at 0, negative 8, and negative 2. This is negative 8, negative 2. My horizontal asymptote, if I were to multiply, actually you can go back to the standard form and you look, the leading term is x squared, the leading term in the bottom is x cubed. So the thing will end up looking like x squared over x cubed, which translates to 1 over x. I know that in the end it's going to have a horizontal asymptote of 0, and it's going to kind of tend in this fashion right here. If I want to figure out the y-intercepts, actually I can tell you right now that this thing has no y-intercept because you can't let y equal to 0 because if you let y equal to 0, that would kill that denominator, and that's a problem. So it has no y-intercept. Or I'm sorry, if you let x equal to 0, that kills that denominator. I'm sorry. As far as the x-intercepts go, all you got to do is basically set this thing equal to 0, but you can multiply everything by the denominator, and so what that ends up translating to is x plus 1 x minus 2. So it's telling you that the x-intercepts in this case is at x equals -1 and x equals negative, or x equals positive 2. How does this graph look? This one's kind of interesting. All right, here's what my guess would be. I'm thinking that let's see, it must come this way. Okay, that's for sure. This jump across this -8 is going to be an odd jump. But it's not going to cross anything over here. So interestingly enough, I think it's going to go up again, like this. It's going to be an odd jump across here, and so it's going to go up like this. And this one's going to go like this. And it must cross right there, so it crosses right there. But it has to tend down towards that, so it's probably going to look something like that. That's an interesting one. Let's graph that and see what Desmos says. X squared minus x minus 2. Okay, let's try that. So on the numerator, x squared minus x minus 2. Is it minus x minus 2? Yep. And on the denominator, x cubed plus 10x squared plus 16x. Okay. X cubed plus 10x squared plus 16x. Whoa! That's my graph. And, oh, I'm going to get rid of all of these guys. Okay. So, I want to compare what this looks like to what I have. Just pull this thing to the side. And then we'll take a look at this thing. And we'll move it to the side a little bit like that. We'll do this. And we'll say, did I get it even remotely close? And the answer is yes, I actually did. I got everything. I got the vertical asymptote at -8. I got another vertical asymptote at -2 and 0. I predicted that that's going to be a parabola. I knew that this thing is going to tend out towards 0. I knew that it was going to only cross at x equals -1. See, that's what I have there. And it's going to go up. I didn't necessarily know the shape of this thing would be as extreme, but don't fault me for that. That's just kind of getting that shape a little bit more. And I knew that it would come up, and then from the positive side of the axis over here, it would start to approach back down to 0. And you can't see that over here because that just kind of looks like it comes up and approaches 0. But actually, if you take a look real close, right here, it crosses from the negative side of the y-axis to the positive side of the y-axis. And then this point on the graph is signifying that that's the highest point over there. So everywhere after that, it's actually getting closer and closer to the 0 axis. Desmos does something nice and actually finds the high points for you. If we were doing calculus, you would have to do that manually, but we're not doing calculus, so c'est la vie. Anyway, that's our graph. I think that's pretty cool.